Hi guys. Okay, so this video is going to take you through the solutions of the area practice and then the 11-4 homework, including the interactive one you did on Canvas. So this is the first one that we did for homework actually. The area of a rectangle with side lengths 7 and 5. So rectangle is just length times width, or 7 times 5, which is 35 meters squared. A rectangle with one side 9 centimeters and the perimeter of 34. So if you've got a rectangle and you've got 9, the other one has to be 9. Then we don't know the other two sides, but if twice times 9 plus twice times the other two sides is 34, you can do 34 and then subtract the 18 from the two 9s. You get 16 and divide that by 2, and it's 8 and 8. So then this would be 9 times 8, which is 72 centimeters squared. Next one is an equilateral triangle with side length of 12. So if I've got equilateral triangle, it means all three sides the same. If the sides are 12, there's actually two ways to do this. I'm going to zoom in on this one. And that is to make them two right triangles, where this would be 6, 6, 12, and 12. And do the Pythagorean theorem. 6 squared plus the height squared would equal 12 squared. 36 plus h squared would equal 144. Subtract 36. H would equal the square root of 108, which is 2 and 54, 2 and 27, 3 and 9, 3 and 3. And so that becomes 2 times 3 root 3, or 6 root 3. So then that's the height of the triangle. And my area would be 1/2 base times height, 1/2 of 12, because that's the original base, times the height is 6 root 3. 1/2 of 12 is 6. 6 times 6 is 36 root 3. And it would be, it didn't give you a unit, so 36 root 3 units squared. The other way that you can work that out is by taking that same triangle, 12, 12, 6, and 6, and making it a 30, 60, 90 triangle. So if it was equilateral, it meant all the angles were 60, which means that this is 60, this is 30. Opposite the 30 would be A, opposite the 60 would be A root 3, opposite the 90 would be 2A. I'd get that A is 6, and so the height would be 6 root 3. So that's actually a little faster than doing the Pythagorean theorem, but again, you do have that choice. Okay, 4 is a parallelogram with base 11 and height 7. Area of a parallelogram is base times height, which would be 11 times 7, or 77 units squared. Number 5 is a rhombus with the diagonals 10 and 12. Area of a rhombus is 1/2 diagonal 1 times diagonal 2. 1/2 10 times 12, and half of 12 is 6. 6 times 10 is 60. And trapezoid, 1/2 height times base 1 plus base 2. 1/2 6. 7 plus 13. So 1/2 6 times 20. Half of 20 is 10. 10 times 6 is 60 centimeters squared. Okay, then we get the area of, on the bottom. The first one is a square with a diagonal of 10. So we can either do a parallelogram, because the square is parallelogram, or you could use your 45, 45, 90 triangle. If this is A root 2, then A is 10 over root 2, or 10 root 2 over 2, or 5 root 2. And then the area is side squared for a square. So 25 times 2, which is 50. Number 9, you can actually break this down in different ways. So depending on how you did it, the setup might be a little different, but the answer overall is going to be the same. So I can draw this way and this way, and I can break those into 3, where if this whole side is 6, this is 4, this is 1. Well, I can take this side here. This would be 2 times 1, which is 2. And then if this whole side is 4, because of the 3 and the 1, and this was 4, but we take away the 2, that means this is 2. So this would be 4 times 2, which is 8. So this is 2, and that whole side is 6, which makes just this part 4. And we've got the 3, the 1, and the 2 here, which makes this whole side 6. So this would be 4 times 6, which is 24. And again, you can break those down in different ways, but then I want to take the 24, the 8, and the 2 and add them together. 34 units squared. Number 10, we are back to a triangle. We don't know that it's we don't know that it's equilateral, but we do know that it's isosceles. So these are the side lengths here, 10, 8. This missing side would be 6, and because it's isosceles, it would be the same for both. And now I get 1/2 the base, which is 12, times the height, which is 8. 1/2 of 12 is 6, and this becomes 48. Now we're looking at parallelogram number 11, where they give you the angle is 30 degrees. So that makes this a 30, 60, 90 triangle. We have the base, right? So we have 13. What we don't have is the height. So this is my 2A side. If 12 is 2A, then A is 6, which means the height of this is 6. So 13 times 6, which is 78 units squared. Okay, now we've got a trapezoid, number 12. You've got the height. You've got this side, but you don't know this base, which we need 1/2 height, base 1 plus base 2. So I can use the fact that this little right triangle exists to know that, and there's a 3, 4, 5 triple there, to know that this would be 3, take the 3 off the 12, and that makes the top 9. So now I get 1/2 the height, which is 4, base 1, which is 9, plus base 2, which is 12. And I can do 2 times 21, or 42. All right, and then 13 is also a trapezoid. This time it's isosceles because these two are the same. So I'm going to drop these sides down, and I would know that from there to there is 8. And then I have to use this 45, 45, 90 triangle to find the height and the base. So if this is a root 2, then a root 2 equals 4 root 2. Divide both sides by root 2. A is 4. That makes this 4 and this 4 and also this 4. So I have 1/2 the height, which is 4, base 1, which is 8, plus base 2, which is 4 plus 4 plus 4. I'm sorry, 4 plus 8 plus 4, or 16. 1/2 times 4, 24. 1/2 of 4 is 2, and 2 times 24 is 48. Okay, so that was the first page. All the areas we supplemented into the chapter. All right, then came calculating the area. So this was extra practice on day 2. This one said number 1 is a triangle, and A is 77, B is 56, C is 95, but we don't even need this side because we need 1/2 the base times the height. 1/2 of 56. You could make that 28, and then 28 times 77. Number 2 is a trapezoid. This is 89. This is 40. And the height is 44. And that's all you need from this one. 1/2, 44, times 40 plus 89. 1/2, 44, plus 129. 22 times 129. (2,838 feet squared). All right, number 3 is now an isosceles triangle. I know that because these are the same. This is 59, this is 59, and this is 45. So we've got to drop down our altitude, which cuts that 45 into 22.5 and 22.5. And then I don't know the angle, so I'd have to use the Pythagorean theorem. 22.5 squared plus height squared equals 59 squared. So this becomes height squared, 2974.75. Square root that. 54.54. That's going to be your height. So then I would do 1/2 the base, which is A, times the height. So I'm going to multiply by 45 and then just divide it by 2. So depending on how you round it, it would have been close to 1,227.18. Okay, number 4 is, we're now going back to the polygon. So 1/2 ANS. 1, 2, 3, 4, 5, 6 sides. They actually give me the apothem 61. And the length of each side is 71. So I could just do 1/2. 61, 6, 71. So 0.5 times 61 times 6 times 71. I get 12,993, and it would be yards squared. All right, number 5 is an equilateral triangle. So I can draw in my altitude, or I could have used the central angle like we did with the regular polygons. You could do this either way. If this is 63, then I know I just cut that into 2 equal parts, which is 31.5 and 31.5. And then I need to find the height of this. So you can... I'm going to use the Pythagorean theorem. But again, you could also use the other way. So this was 63. So I would say 31.5 squared plus the height squared equals 63 squared. Or we could do what we did before. This is 30, this is 60, and this is 90. This would be A, this would be 2A, and this would be A root 3. So my height would be 31.5 root 3. And I do 1/2 base, which is 63, times the height, 31.5 root 3. But again, you could have done central angle, so I could have drawn my central angle. That would have been 120, cut it in half. Now that makes it a 60, 30, 90 triangle, in which we knew the side opposite the 60, and we could use that to get the apothem. So that's the other way to do these. Number 6 is back to easy stuff. Your rectangle, which is 85 times 44, because it's base times height, which is 3,740. Number 7 is now a parallelogram. So you've got A, which is the side length here, which we actually don't need right now. C, 92, and H, 56. This is just base times height, or 92 times 56. 5,152 millimeters squared. The next one's a square. I just do side squared, or 67 squared, 4,489 inches squared. And number 9, back to a parallelogram. A is 63. Height is 57. So I just have to do 63 times 57. Okay, number 10, we're back to 1, 2, 3, 4, 5, 6, a hexagon. All we have is the length of each side being 8. So we don't know the apothem this time. We would have drawn our central angle, which would have been 360 divided by 6. That would have been 60. And then we would have cut it in half, 30, 60, 90. We'd cut the side length in half, so it's 4. So our small triangle that's inside that central angle looks like this. I need the apothem. So this is A in reference to the 30, 60, 90. This would be A root 3, and this would be 2A. So if 4 is A, then the apothem is 4 root 3. And then you don't need the 2A side. You don't need the radius. So we have enough right now. And this would be 1/2, 4 root 3, 6, 8. So I can do 1/2 of 4 is 2. That's 12. And 12 times 8, 96 root 3. All right, number 11, we're back to the square. This time we have the diagonal. This is 8. Remember, the square is 45, 45, 90. So you can either do the Pythagorean theorem with both the side lengths the same, or we could say that the 8 equals the A root 2. So A would equal 8 over root 2, or 8 root 2 over 2, which is 4 root 2. And that becomes the side length. And then I would just do 4 root 2 squared, which is 16 times 2, or 32. Remember that a square is also a rhombus. So if you know one diagonal is 8, you could also use the other diagonal as 8. So it'd be 1/2 8 times 8, 1/2 64, which is 32. So you get the same answer either way. Okay, that wrapped up the extra practice, the first one. Now let's look at the Canvas Webassign. So these said, and they might have been in different order, but they were the same questions, obviously just rotated around. This one said, find the area, and we're talking about the area of a circle now. So area of a circle is pi r squared, and it said to use the pi on the calculator. So this would be pi times 3.5 squared. So then I would do 3.5 squared in the calculator. That's 12.25. And then I can just multiply it times pi. So not 3.14, but actual pi, because you want it to be as accurate as you can. And you'd get 38.484, which actually this answer used pi as 3.14. So this is, if you had used 3.14, you would have gotten 38.465. Okay, number 2 said find the area of the parallelogram with base 12 and height 8. So it's just 12 times 8, which is 96 inches. Next one said find the area of an equilateral triangle with side length 14. So 14, 14, 14. Would have cut the height down the middle. This would have made this 7 and 7. And we're back to that 30, 60, 90 triangle, where opposite the 30 is 7, which means opposite the 7, or the 60 would be 7 root 3. And I'd get 1/2 14 times 7 root 3, or 7 times 7, 49 root 3. Number 4, the regular hexagon has an apothem of 2 and a side length of 4 root 3 over 3. Its area is, so 1/2 ANS, 1/2, apothem is 2. Number of sides if it's a hexagon is 6. Length of each side is 4 root 3 over 3. So 1/2 of 2 cancels out. 3 can go into 6 twice, and 2 times 4 would be 8 root 3. which was this one. Number 5, the area of a trapezoid, base 1 is 8, legs are 10. So if this is 10 and 10, and this is my triangle, right? Then this would be opposite 30, 90. This would be 2A, making A 5. Now these are 5, and these are 8, which makes this whole side 18. So 1/2 8 plus 18 times the height, which would be 5√3. 1/2 26, 5√3, 13 times 5√3, or 65√3. Number 6, find the area of the shaded region, use pi on the calculator. So we are back to now area of a sector, which is the measure of the arc over 360 times the area, or pi r squared. So if this is 72 degrees, then I put 72 over 360 times pi times the radius, which is 7 squared. So this can actually get reduced to 1/5. 1/5 times pi times 49. And I can multiply that all out. So 49 over 5, is 9.8 times pi, which is 30.787, or 30.79. And number 7 says, if a point is selected at random, what's the probability that it will lie within the shaded rectangular region rather than the unshaded rectangular region? Enter your answer as a reduced fraction. So this was 11/4 because this is geometric probability. We need to find the area of the shaded region, right? Because it says the shaded region over the area of the entire rectangle. So the bottom's easy. That's just 21 times 15. So the whole. Which is 315. And then we have to find the area of the shaded. So in order to get the shaded, we have to find the area of the whole and subtract from it the area of the white rectangle, the smaller one. So we just said the whole is 315. The small one would be 7 times 7, or 49. 315 minus 49 is 266. So then I put 266 over 315, and I start reducing. These are actually both divisible by 7. It would be 38 and 45. Which is as simplified as that number gets. Okay, number 8 said find the area of a rhombus that has diagonals 12 and 16. So rhombus is 1/2 diagonal 1 times diagonal 2. 1/2 of 12 is 6, and 6 times 12 is 96. Okay, back to 11/4. In this figure, each circle has a radius of 2 inches. What's the area of the portion outside the circles but inside the square? Express your answer in terms of, that should have been pi. Actually, this is not probability. Sorry, this is area. We're just trying to find the area. So I have to find the area of the whole square and then subtract from it the area of 1, 2, 3, 4, 5, 6, 7, 8, 9 circles. So if the radius is 2, that's 2, that's 2, that's 2, that's 2, that's 2, that's 2, 2, 4, 6, 8, 10, 12. That means this entire side is 12, and the same thing will happen that way. Each of those diameters would be 4, and this would also be 12. So the area of the whole is 12 times 12, or 144, minus the area of 9 circles. Each circle has a radius of 2, so 9 times pi 2 squared would be 9 times pi times 4, or 36 pi, which is that first option. Number 10 says for a circle of radius 5 feet, find the length of an arc S with a measure of 28. So we're doing length of an arc. Length of an arc is the measure of the arc over 360 times 2 pi r. So the arc measure is 28 times 2 pi, and the radius is 5. 4 goes into both of these, 7 and 9, D, and then I can do 2 and 5 is 10, 10 and 90 is 9, so this is 7 over 9 pi. Okay, 11. A circle has a diameter of 7 inches. What's the circumference rounded to the nearest whole number if pi is 3.14? So circumference is pi d if you have the diameter. So I would do 3.14 times 7, which is 21.98. Nearest whole number would be 22. And this was just your work, so you had to upload your work to get full credit on that assignment. All right, last one for the week was the 11-4 homework. So now we're talking geometric probability. 3, 4, 5, and 6, we're dealing with length. It said in exercises 3 through 6, find the probability that point K selected at random on AE is given on this segment. Express your answer as a fraction, decimal, and percent. So the very first thing you have to do is, because you'll need it for all of them, is figure out what AE is. So from 12 to negative 12, that's 24. So the length of the whole line, or whole segment, is 24. So then we want to take each of the ones that they asked for and put it over 24. So AD. Okay, so from A to D, it's negative 12 to 3. 3 minus negative 12 becomes 15. So 15 over 24, which are both reduced by 3. That's 5 over 8. That's your fraction. Your decimal, 5 divided by 8 is 0.625. Percent would be, you move that decimal twice, 62.5%. So fraction, decimal, percent. Number 4 is BC. So BC just goes from negative 6 to negative 3, which is just 3 units. 3 over 24 is 1/8. 1 divided by 8 is 0.125. And as a percent would be 12.5%. Okay, DE goes from 3 to 12. That's 9. 9 over 24, which again divisible by 3, 3/8, which is 0.375 or 37.5%. And 6 says AE. So AE is the length of AE, which would mean it's 24 over 24. That's going to be 1. That decimal is 1, and that percent is 100%. Number 8. So number 8, 9, and 10 said to find the probability that a randomly chosen point in the figure lies within the region. So we're doing this time the area of what you want. So in this case, it's the shaded over the area of the whole. So for number 8, the shaded is outside the square. We're going to have to do the area of the circle minus the area of the square to get the shaded region, and then we'll put it over the area of the circle. So because the radius is 2, I would know the circle is pi r squared. Pi times 2 squared, which is 4 pi. So that's the area of the circle. The area of the square, if this is root 2, this would also be root 2. So my side length would be 2 root 2. And the area of the square would be 2 root 2 squared, or 4 times 2, which is 8. So I get 4 pi minus 8 over area of a circle, which again is 4 pi. Now all of these numbers are divisible by 2, or actually by 4, so we can reduce this only because all of them are. If just part of them was, we couldn't do it. So 4 goes into itself once and here twice. So this would be pi minus 2 over pi. If you didn't have a calculator, you would leave your answer that way. If I actually put that in the calculator, pi minus 2 divided by pi, I get 0.36 once I round. So without a calculator and with a calculator. And if it asks for it in percent, it'd actually be 36%. So usually a standardized test would ask it in that percent. Okay, so now let's look at number 9. Number 9 is, again, area of the shaded region. So I need the area of the small triangle over the area of the big triangle. So my small triangle, this is 14, but it says these two are congruent. Or sorry, this whole side is 14. These are congruent, which makes that 7. So the small triangle would be 1/2. The base is 6. The height is 7, which is 21. And the big triangle is 1/2. 12 times 14. Or 6 times 14, which is 84. And that reduces to 1/4, or 0.25, or 25%. Number 10 has a trapezoid and it has a rectangle in the trapezoid. So in order to find the shaded area on the outside, if I knew the information about the triangles, I could use that, but I don't have the breakdown of the sides here and here. So I'm going to have to do the area of the whole trapezoid minus the area of the rectangle over the area of the whole trapezoid. So the whole trapezoid would be 1/2 5 times 8 plus 20. 1/2 5 times 28. 1/2 of 28 is 14, and that's 70. The area of the rectangle is just 5 times 8, or 40. So 70 minus 40 over 70 is 30 over 70, which becomes 3/7. And 3/7, or 3 divided by 7, is 0.4289, or 85, which becomes 43%. Okay, that was the first page. Next page says, in exercises 16 to 19, find the probability that a point chosen at random will be on the segment that satisfies the inequality. So here's a little bit of algebra coming back into play. If I've got an inequality that says x minus 6 is less than or equal to 1, then I'd have to add the 6, and I get x is less than or equal to 7. So less than or equal to 7 means I include 7 and everything to the left of it. So 2 to 7 would be 5 over the entire segment, which is 9 to 2, or 2 to 9, sorry, which is 7. So 5 divided by 7, 0.714, or 71%. Number 19, I would divide both sides by 3. And I'd get x is less than or equal to 9. Less than or equal to 9 means it's the entire segment. So this would be 1 over 1, or 100%. Number 20, find the probability that a random chosen point in the figure lies in the shaded region. So I've got to find the area of just the triangle over the area of the trapezoid plus the triangle, because that shape is not an actual shape. So triangle over area of the triangle plus the area of the trapezoid. So the triangle, I have 3 and 5. The height here would be 4 because that's a right triangle. So the area of the triangle would be 1/2. 3 times 4, or 6. And the trapezoid would be 1/2 the height, which has to be the perpendicular distance, 3, And then 5 plus 7. 1/2 of 12 is 6, and 6 times 3 is 18. So triangle was 6 over 6 plus 18, 6 over 24, which is 1/4. Or 25%. Okay, 21. Now you've got a trapezoid on the bottom, which is your shaded region. And then you've got, you could actually use the big triangle as the whole shape. So I have to do the area of the trapezoid over the area of the triangle. So trapezoid would be 1/2 base 1, which is what we don't know. So this is where this one gets a little tricky because we're missing that bottom side. So you have to pull in similar triangles here. If you remember, this would be, so if these are congruent and these are congruent because they are consecutive, they're corresponding angles. That makes the small triangle similar to the big triangle because of angle-angle similarity. And if that's the case, then we can use the ratio. So if this is 8 and this is 12, that means that the ratio of the small triangle, so if I did 12 minus 8, I get 4. That's this one. The ratio of the small triangle to the big triangle would be 4 to 12, or 1/3. So if I have 14 here, then I can say 1/3 equals what to 14? And x would equal 14 over 3. So now you've got the bottom side of that triangle, which is also the top of the one base. So I could do 1/2 the height, which is 8, 14 over 3 plus 14. This is 4, 14 over 3. If you wanted to give it a like denominator, would have to be 42, so 4. That's the area of the trapezoid. And then the area of the triangle, the big triangle is what we're talking about. 1/2 base times height. So then I would have to keep change flip. This would be 84 over 1, which becomes 1 over 84. And then we can start reducing those. So you could do by 2, which is the obvious one. 112, 126, 56, 63, and 7 goes into both of those, 8/9. So the other way to look at these is if you remember the ratio of similar triangles, like if you get the ratio of their areas, the ratio of the lengths, then which is that scale factor, which was 1 to 3, right? The ratio of the side lengths or the height is going to be the same as the perimeters. It's the same as the scale factor, which is 1 to 3. The ratio of the areas is that squared. So the ratio of the area of just this guy to the whole thing would have been 1/9. And we're removing the 1/9. So it actually ends up being 9 minus 1/9, or 8/9. So that's the other way to look at it. Obviously, this one was a little bit more complicated, but that's another way to look at the same question. All right, 22. So 22, we want the area of this shaded region here. So I'm going to have to find the area of this entire arc and then subtract from it the area of these triangles. So because this is 90 degrees, I know the area of the arc. I'm sorry, the length of the arc. The measure of the arc is 90, so 90 over 360 times pi. The radius is 8. So this is also where it gets a little tricky because we're back to a 30, 60, 90. I mean a 45, 45, 90 triangle. We just divided that in 2, 45, 45. If that side, the apothem is 8, then this would also be 8, but the radius would be 8 root 2. So this is 8 root 2 here. So this becomes 1/4 times pi times 64 times 2. 4 goes into 64. 16 times this is 32 pi. So that's the area of the sector there. And then I have to subtract from that. So I'm doing the sector minus the triangle over the area of the whole circle. So this is the sector. Now I have to do the triangle. So this is an isosceles triangle where the height was 8. This side length was 8 root 2. This side would also be 8, which makes the base 8 plus 8 or 16. So triangle would be 1/2. 8 is the height. Base is 16. So 1/2 of 16 is 8, and this makes us 64. So the area of the sector is 32 pi minus the area of the triangle, which is 64 pi. That leaves that little shaded region. And I want the area of the circle, which the whole circle is pi, radius, which is 8 root 2 squared, pi 64 times 2, 128 pi. So if I had, if I didn't have a calculator, then I would just reduce these. They're all divisible by 32, actually. This would be 1, this would be 2, this would be 4. And I get pi minus 2 over 4. And then with a calculator, you would do pi minus 2 divided by 4. And I'd get 28%. 28.5, so it would be 29 or 29%. So without a calculator, it would stay like this. With a calculator, you would see it one of those ways. All right. Number 23 says point X is chosen at random in the region. Let me erase this off so we can see. In region U, and U includes region A. What's the probability that X is not in A? So I want the probability of basically the blue, not the red. So I'm going to do the area of U minus the area of the red or the A all over the area of U, which is D. Okay, then we did the quiz questions, which is just the review of the areas that we had already done. So this is the area of the polygon, 1/2 ANS. So A is the apothem, which we don't know. The number of sides, 1, 2, 3, 4, 5. And the length of each side is 20. So this took us back to the calculator portion of this section, which told us that we had to find the central angle here at the top. If it's 5, then it was 360 divided by 5, which is 72. Take that, cut it in half, and I'm dealing with a 36 at the top. So I have a small right triangle there with 36 here. And if the side length is 20, then this bottom side's 10, and I need the apothem. I have to use tangent. So the tangent of 36 is 10 over A. And then remember, in the numbers in the top, we take the top number and divide it by the tangent. So 10 divided by tangent 36 gives me A, which is the apothem, is 13 point. We're going to round it to 8. So 13.8. Number of sides is 5. Length of each side is 20. And then we're just going to multiply that out. And I get 690. centimeters squared. Number 2, 1, 2, 3, 4, 5, 6, 7, 8 sides. So again, we don't know A. The number of sides is 8. The length of each side we don't know either. What they gave you this time is the radius. So we could draw these radii anywhere because they'll all be the same, 25 and 25. Now I'd have to do the 360 divided by 8, which is 45. That's the big angle at the top. As soon as I draw in the apothem, I take that 45 and I cut it into 22.5 and 22.5. So now I've got a triangle on the inside. That's 22.5 at the top. And I know only the radius, which is 25. So I'm going to call this X because it's half of the side length. And I need the apothem. So the first one I'm going to do, let's say I want to solve for X. I'm going to use X and 25, which in respect to the 22.5 is opposite, and hypotenuse, which means we're using sine. So the sine of 22.5 would be opposite over hypotenuse, numbers in the bottom this time. So 25 times the sine of 22.5 is going to give me X. So X is, we're going to round it to 9.6. Now that's half the side length. So I have to double it or multiply by 2 to get S. 19.13. And then the apothem is here. So I'm going to stick to the 25 because I know that that's right and hasn't been rounded. In respect to 22.5, A is adjacent. 25 is hypotenuse, which means cosine. Cosine 22.5 equals adjacent over hypotenuse, and I get 25 times the cosine of 22.5. A is 23.1. So now 1/2 A and S. Which is 1764.84 meters squared. So these didn't tell you, obviously, what to round to. We're kind of guessing what we're rounding to, but those definitely needed a calculator. If and when we do test on this, this would be on the portion of your test that you'd have a calculator, and it would be specific as to what to round to. All right, 3 and 4. Find the probability that a random chosen point in the figure lies in the shaded region. So this is that 11/4 probability. I would try to find in the first one, I want to get it in the shaded region, which means it's the area of the small circle over the area of the big circle. So 3 is actually pointing at the middle here, which is telling you that that is the diameter of that circle. So the area of the small circle is going to be 1/2 or 1.5 or 1.5 squared times pi r squared, or 1.5 squared. Or 2.25 pi. If you did it as a fraction, it'd be 3/2 squared times pi, or 9/4 pi. So either way, that's the small. The area of the big circle, this again is in the middle, so that's telling you that that's the diameter. So the radius would be 5. So it would be pi 5 squared, or 25 pi. So the area of the small, you can either do it as 2.25 pi over 25 pi, or you could do 9/4 pi over 25 pi. Okay, either way, you can't leave a decimal inside the fraction, and you can't leave the fraction inside the fraction. So if I move this 2 places, I'd move this 2 places, and then reduce that. The pi's are going to cancel out. This would be 9/10. and those would cancel, and I just get 9/10 because they're both divisible by 25, so it'd be 9/10. And then here I'd get 9. First of all, the pi's cancel over 4 over 25, which would be over 1, and then keep, change, flip. And I'd get 9 over, sorry, that's 9 over 100, over 100. So either way, 9 over 100 or 9% if it asks for it in percent. And for you are looking for the area of the shaded region, which this time obviously we can't just find that. Those are weird shapes. What we have to do is find the area of the trapezoid, the white trapezoid, and subtract it from the area of the hole. So area of the rectangle minus area of the trapezoid over area of the rectangle. So rectangle is easy. It's 5 times 8 or 40. And then the trapezoid, you've got base 1, which is 3, base 2, which would be 5 because it's the same as the side length, and then the height, which is 2. So 1/2 height, base 1 plus base 2. This cancels, and I get just 8. So rectangle is 40 minus trapezoid, which is 8, over rectangle, which is 40, and this is 32 over 40. And 8 goes into both of those, 4/5 or 80%. Okay, a lot of work this week. Keep it up. Keep trying. Don't give up. And obviously reach out if you've got questions. We are going to move on in 2 weeks, and then we'll figure out the assessment when we get back to school. So just keep up with your work. And again, if you've got questions, we're going to be able to meet on Zoom so that I can answer them a little bit more clearly. I miss you guys. I hope everybody's doing well, and I will talk to you soon.